Welcome back. In this lecture, we will learn about row elimination. We will learn what is row elimination, how it works, and how it can be used to optimize performance of your Spark application. So let's start with the scenario. I have designed a scenario for understanding the row elimination. The code is available in Scala and Python both. For this lecture, I'll be using Scala notebook, but there is no difference in Scala and Python for this scenario. You can use both the languages in the same way. So let me go to my notebook where I have this scenario set up for you. So let's start with the problem statement. I have a team. They have built one Spark job which reads data, does some processing, and produces the output in the target table. But they noticed something and they came back with the observation. So what is the observation? We applied the filter condition and read 1/3 of the table. So they are reading data from a table. They have applied some where condition, some filter conditions on that. And the filter condition is designed in a way that it is reading only 1/3 of the data. Rest of the data is filtered out. The filter condition is being applied and the query is returning the correct result. So they verified that filter condition is working indeed, right? And there is no functional problem. Filter condition is doing its job. However, we observed the following behavior. There are 3 observations that my team has noticed. Time to read without filter condition is X minutes. So basically they are saying if we do not apply any filter condition on the same table and read the entire table, it's taking approximately 2 minutes, for example. But when we apply the filter condition, then time to read the subquery and filter condition is close to X minute. It's taking maybe 1.7 minutes or 1.8 minutes after applying the filter, which is almost like 2 minutes, right? So 2 minutes here, 1.7 minutes or 1.6 minutes here. But in this filter condition, they have a subquery and filter condition is implemented outside that subquery. So what they thought, maybe because of that filter is not applied at the beginning. So they try to tune the query or kind of restructure the query, eliminate the subquery from it and apply the filter condition directly. So time to read with tuned filter condition is also close to X minutes. So that's the problem. That's the problem statement. Why it is a problem? Because if you do not apply the filter condition and read the entire data, it's taking 2 minutes. If you apply the filter condition and read only 1/3 of the data, it should take 1/3 of the 2 minutes, but it is taking very little less than the 2 minutes, maybe 1.7 minutes or 1.5 minutes, right? It's not 1/3. So what is missing here? Linear scalability is missing. Your query is not linearly scalable compared to full data versus filtered data. So ideally it should be like if full data is taking 2 minutes, reading 1/3 of the data should take 1/3 of 2 minutes. Reading 50% of the data should take 50% of the 2 minutes, right? So that is missing and that's concerning my team. So they came up with the question. We have the following question. Why reading 1/3 of the data is not taking 1/3 of the time for reading the complete data set, right? That's a genuine concern. If I'm reading 1/3 of the data, it should finish in 1/3 of the time. How can we achieve linear scalability for the filter query? That's the question. What can you do to actually make sure it is linearly scalable? It is taking 1/3 of the total time.